So we nuked number 6. I think we said it was out of 21, right? And good old Anne. Given the following massless, frictionless pulley, you know what? Given the following Atwood machine, where M1 is 21.3 and M2 is 19.6 kilograms, find the acceleration. I'm going to start with a free body diagram. What are the forces acting? I'm going to have M1G tension, M2G tension. Is there a normal force? Why not? What do we have to have for us to have a normal force? We have to be sitting on a surface. It could be a wall. It could be leaning against a wall. It could be sitting on the ground. But there has to be a surface. If you're hanging in midair, no normal force. Who's winning? Well, mass 1 is bigger, so I think this is accelerating down. This is accelerating up. I didn't draw those arrows on my free body diagram because I like to have only forces on my free body diagram. But if you find that helps you remember which way, Cam, feel free to add those if it helps. So I think my equation is going to be M1, and as I say 1, I write it 2, M1G minus tension. And then this tension here, when it gets over to this side, it does end up pointing straight down. It does become a winner. And M2G ends up being a loser, and that's going to be, since I have more than one mass on the left, I'm going to have more than one mass on the right. I've been having a stressful morning with my technology, with things not working. I've looked forward to this question. Do you know why I've looked forward to this question? Oh, I get to lose a bit of tension. Whew. Now I'm in my happy place. They want me to find the acceleration. Luke, how would I get the A by itself? Or divide by the bracket, as many of us like to say. So it's going to be the M1G is going to drop down like a domino. The M2G is going to drop down like a domino. And it's going to be over M1 plus M2. It's going to be M1 21.3 times 9.8 minus 19.6 times 9.8. Was it 19.6? Yeah. All over 19.6 plus 21.3. Tricks of the trade. You ready? If these two masses were identical, what would the acceleration be? 0. Are these masses really close to being identical? Yeah. I don't think we're going to get a real big acceleration. I don't think I'm going to be getting like 8.5. I'm betting it's going to be fairly small. What's the maximum acceleration that I could get if the rope was cut? So I actually have a built-in error check, but even more so, because these guys are fairly close together, I'm kind of guessing actually not that big an... You guys probably... definitely less than... Was it less than 3? Yeah, see, I already have a gut instinct over what my answer should be. That helps take care of typos on my calculator, and I still can't get my good calculator working, so I got to go with this one. Is it 21.3 or 21.4? 21.3? Yeah. I copied it over. 19.6, 9.8. Do you get 0.407? 0.41? Yes. 0.40, I'd take a half mark off and I'd say learn to round off. I'm going to go 0.407 units. It's an acceleration. Units, it's an acceleration. Meters per second squared. If you got that 4 out of 4, otherwise I would go something like this. 1 mark for that, 1 mark for that, 1 mark for the numbers, and 1 mark for the answer. Find the tension in the cord. I'm going to find the tension in the cord using mass 2 because tension is winning. You could find it using mass 1. You'll get the same answer. I'll take either on the test. It's just I'm lazy. Haven't figured that out, Mr. Dewick. Tension minus M2G equals M2A. How come I don't have M1 plus M2 over on this side? Because I didn't take forces from more than one mass over on the left-hand side. I'm only using the forces from one mass. Which mass? M2. So which mass is going to be on the right, Isabella? Mass 2. Isabella, what am I trying to get by itself? How would I get the t by itself? Remember how tough that seemed a while ago, and now you're looking at me like rolling your eyes? Duh. I love it. M2 was 19.6. A, 0.407. I'm going to use my answer button. Plus 19.6 times 9.8. You get 200? I guess 200. 200.1 to 4 sig figs. 4 sig figs is a bit excessive, so I'm going to go 200. I'm going to put a dot there to 3 sig figs. If you didn't, I'm not going to take a mark off because it's obscure. Units, it's tension. It's a force. How many marks? 3. How about 1 mark for that, 1 mark for that, 1 mark for the answer? But if you got the right answer, 3 out of 3. Now, if you got this wrong, but you dropped it down here and you went 19.6 times your answer plus 19.6 times 9.8, and you did that correctly, I would give you 3 out of 3 for this. Did anybody use tension 1? You would have M1G minus tension equals M1A. You would have tension equals M1G minus M1A, but you'd still get 200. Okay. Number 3 is tricky, but I think I like number 3. I like number 3. I like number 3. The reason number 3 is tricky is there's extra vertical forces. What are the forces acting on this? I do have gravity down. I have normal force up, but people are saying, Mr. Duke, isn't that the normal force? No! Otherwise I would have called that Fn. I just called it F. Someone is lifting up with 15 newtons. Who? I don't care. There's an applied force up, as well as an applied force sideways, and friction. I didn't really leave you much room for this. I should have, well, okay. I should have made this top diagram smaller. I can do that next year. What does this want me to find? Acceleration. Which way is this going to accelerate? To the left or to the right? Or up or down? I think to the right. So I'm going to write a horizontal force equation. Who's winning? I think the applied force. Who's losing? Friction. That equals MA. Isabella, how would I get the A by itself? I totally agree. We're going to have, let's see, where am I going to write this, Mr. Dewick? I guess right here. Acceleration is going to be the applied force minus friction all over m. Do I know the applied force? Yeah. Friction is what times what? This is going to be, well, friction is going to be mu times the normal force. I don't know the normal force. Oh, but look, ugh. It's going to be mu. How big is the normal force going to be? Well, everything up has to equal everything down. Remember, I used to always say to you guys, is it sinking to the ground like quicksand? Is it flying to you like Superman? What I really, Derek, was getting you to realize is if you're on a surface and you're not going up or down, everything up has to equal everything down. Hayden, I want to get the Fn by itself. How do I get the Fn by itself? Okay, so it's going to be this. Okay? It's going to be 12 minus mu 0.48 m 3.6 times 9.8 minus 19 all over 3.6. Kind of wandering all over the place because I didn't leave you guys enough room. I'll change that next year. 12 minus 0.48 bracket 3.6 times 9.8, take away 19. Close off that bracket. Close off the top, divided by 3.6. Mr. Dewick, could we have calculated friction and just written that in the... Yeah, but I like to try and do it all in one fell swoop. It's a calculator nerd thing. And you get, is it 1.162, or 1.16 meters per second squared? If you got that... 3 out of 3. Otherwise, I would give you a half mark if I saw that. I would give you a half mark if somewhere I saw that you would clued in that the normal force was equal to mg minus 19. I would give you 1 mark for that. That's 2 out of 2. I would give you a half mark for that and a half mark for the answer. If you just use the normal force equals mg, which it does not, well, first of all, you would get that's a problem, Mr. Dewick. Oh, you'd get a strange negative answer, would you? I guess you would. Why? Oh, because friction is bigger without that. You know what? The fact that I got a negative answer, if we hadn't lifted up, we couldn't have slid this thing. Friction is too big. Anyways, if you said 1.37 and you just ignored the negative because you were terrified, I guess I'd give you 2 out of 3, but I'd say, hey, there's an extra vertical force in here. Is that all right? Turn the page. Consider the 12 kilogram mass below. What would be the acceleration of the mass? Assume there's no friction. No friction. Who's winning? Really? Who's winning? 60. Who's losing? I think I can just go like this. Winner minus loser equals MA. Hey, Isabella, how would I get the A by itself? So the acceleration is going to be 60 minus 36 divided by 12. I think I can do that in my head. 60 take away 36 is 24 divided by 2. Yes? I guess 1 mark for that. Multiple choice. You'll notice I didn't even bother drawing a vertical diagram. I could have mg down, normal force up, but you know what? They were irrelevant to this question because there's no friction, and they told me, looking at those two forces, I took a shortcut. Is that okay, Hannah? Let's keep going. Draw a free body diagram clearly showing. Okay. Did they give me space? By the way, I like this question. I like this question. I like this question. They gave me space. They want me to draw the free body diagram here. So I guess even though they gave me the picture, I'm going to represent the mass with a dot. What are the forces acting on it? Get the obvious one. What else? Bigger, smaller, or the same size as gravity? When I ask you that, what am I really asking? Are there any other vertical forces? Okay? That's the next checklist now, Nevada. Go look. Are there any other vertical forces? No. Then normal force has to be the same size as gravity. What else? If applied. What else? Sorry? Bigger, smaller, or the same size as if applied? How many lines did I just draw? 4. How many marks is this worth? What would be a clever marking scheme? Half mark per line. And I'm going to be fussy. If you drew friction longer than F applied, I would take a half mark off. If normal force and mg weren't the same size, I would take a half mark off. Or on this question, if I'd given you this question and said draw a free body diagram, and you drew normal force the same size as mg, I would take a half mark off. So there's my free body diagram. 0.5, 0.5, 0.5, 0.5. Find the acceleration. Who's winning? Applied. Who's losing? Friction. What does that always equal? Since there's only one mass, ma. Hey, Isabella, how would I get the A by itself? It's going to be F applied minus friction is mu times the normal force all over m. I don't know the normal force. Oh, but look, 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 look. I know another force the same size as the normal force. What? What force is the same size as the normal force? mg. So I'll make a little note here. I can plug in mg. So it's going to be F applied 225 minus, hey, what's mu? I don't know, what's mu with u? There it is, 0.15 times 100 times 9.8 mg, all divided by 100. Can I do this one in my head? Yeah, but I'm going to be lazy. I mean, it's timesing by 100 and dividing by 100. I should be able to do it in my head. You get 0.78? Barely enough to get it going. Friction is almost, but not quite bigger than what we're pulling with. This would slide slowly. 0.78 what? Units. Yeah. If you got that 2 out of 2, otherwise I would give you a half mark for that, a half mark for that, a half mark for the numbers, and a half mark for the answer. Number 5, given the following system, find the acceleration of both masses. Oh, cool. Pulley, cliff, I like this. M1G, normal force number 1, because there's no other vertical forces acting on that box. Tension, friction. M2G, tension. I think that's it. Who's winning? Really? Is there any way that if you put a box on a table, it will magically start pulling things up to the left? In other words, if you put a box on a table and hung a weight from it, and then you walk away, is there any way that the box will suddenly start lifting the weight up? No? So can we agree that friction's not winning? Who's winning? M2G. Because everything's going this way. Everything's going that way. So, who's winning? M2G. Anything that ends up pointing down when it gets to that section there is going to be a winner plus. I have a tension that's going to be a loser. I have another tension that's going to be a winner. I have a minus friction, and you know what? I'll call that friction force number 1 to go with mass number 1. Same with I called it normal force number 1. You don't have to, but I will just to be clear. Equals, I have forces from more than one mass on the left. I better have more than one mass on the right. Spring break is coming. Tension is lowering. Isabella, how would I get the A by itself? So I'm going to get A equals the M2G is going to drop down like a domino. Friction force 1 is going to drop down like a domino. M1 plus M2. Friction is what times what? Why? That's mu times the normal force. I'll put a normal force number 1 to remind myself, make sure I look at mass number 1. All over M1 plus M2. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. M1G. Acceleration is going to be M2G minus mu M1G all over M1 plus M2. M2, 4.6 times 9.8 minus mu 0.19 times 6.3 times 9.8 all over 6.3 plus 4.6. What do we get? Bracket 4.6 times 9.8 minus 0.19 times 6.3 times 9.8. Close off the top, divided by bracket 6.3 plus 4.6. Double check for typos. 4.6 times 9.8 minus 0.1, I think I'm right. Do you get 3.0, I guess 6? No? Yeah? People, yeah? Yeah, 3.06. Units, meters per second squared. It's an acceleration. If you got that, 4 out of 4. Otherwise, I would probably give you 1 mark if I saw that. I would give you 1 mark if I saw that. I would give you 1 mark for the numbers and 1 mark for the answer. Find the tension in the rope. I'm going to use mass 2, even though tension's a loser. Mass 1 looks yuckier. By the way, in mass 1, it would be tension minus friction 1 equals m1a, and it's perfectly doable. Friction is what times what? Mu times the normal force. I'm going to use mass 2. I'm going to go m2g minus tension equals m2a. Because, Braden, we've done this little dance before, haven't we? I'm going to get m2g minus m2a. Braden, do you mind? I'm going to put tension over here on the left because that's where I'm used to seeing the thing we're trying to get by itself, it's going to be m2, 4.6 times 9.8 minus 4.6 times, I'm going to write 3.06, but of course, Cam, I'm going to use my answer button. 4.6 times 9.8 minus 4.6 times answer button. Ah, I did a minus. Son of a gun. Okay, I'm not going to use my answer button because now my answer is a new answer, so this isn't going to work. Minus 4.6 times 3.06. You don't get 59. You get 31. Is that right? Yeah. Point something. Who used the answer button? Do you still get 31.0 even with your answer button? Okay, no one knows. 31 newtons. How would I give up part marks? I would give you 1 mark if I saw that. I would give you a half mark for that. And I would give you a half mark for the answer. Can you give yourself a lovely score on the top out of 21, please? Right there. So the quiz, the test, 17 multiple choice, and then 31 marks worth of written, but that's only about, I think, 9 or 8 questions because they have part A, B, and C and things. Lots of part marks. Part of the message is don't leave any of the written questions blank. Okay. What are some questions that I like? So from Forces quiz number 1, even something as simple as number 2. Now the key for number 2 is when I talk about net force, I'm saying, oh, for Pete's sakes, you can just go F equals ma, and I figure it's fair game. I give you any 2, you can find the third. If I give you the mass and the acceleration, you can find the net force. If I give you the net force and the mass, you can find the acceleration. Isabella says, yeah, divide by m. If I give you the acceleration and the force, you can find the mass. Okay? Oh, the screen is still frozen. Thank you. So from quiz number 1, something like number 2. Totally fair game. There's going to be something like number 3 and or 5, where I ask you either to find an acceleration using VF, VI, A, and then use that to find a force, or use forces to find an acceleration, and then use that acceleration to find a VI or a VF or a VA or a T or a D. Okay, so all the stuff is still fair game. Very similar, also like number 6. There's absolutely number 8. I like number 8. There's going to be an elevator question or 10 on your test. There's going to be more than one elevator question. You know what? I'll even be more specific. I'll bet you there'll be one question where the elevator is accelerating up. I bet you there'll be one question where the elevator is accelerating down. I might even do a constant speed question or a free fall question. I don't know, but I can tell you there's going to be at least those 2. I'm going to be asking you to tell me what a scale reads. What am I really asking you to tell me? Normal force, okay? Now, on this quiz, I gave you the mass in kilograms. What if I gave you the weight? What's the difference between mass and weight? More specific. What's the difference? What are the units for weight? Newtons. If I told you that they had a weight of I don't know, I'm going to make this up, 1,200 newtons. How can you figure out what mass that is in kilograms? Divide by 9.8. Or if I ask you to find a weight and I give you a mass, times by 9.8. So make sure you're straight. Weight is a force. Weight is mg. And yeah, it depends on where you are in the universe. It's changing. But there is going to be one question somewhere on your test. You better read carefully. There's going to be at least one question where instead of giving you the mass, I give you the mg, the weight. And I'll use the word weight in front of it, and I'll use newtons after the number. Okay? It's definitely an elevator question. Hey, let's look at quiz number 2, number dos. There will be a question somewhere where I ask you to find, hey, what's mu? I don't know, what's mu with you? It might be like this, where you have a constant speed, or it might be... you know what? There might be one where I actually give you an acceleration, but there's going to be something to do with friction. You know, I look at quiz 2, and to me, quiz 2 is a bridging quiz. It's a little too easy still. Quiz 3, the one we just did, I'll tell you which questions that I like. Oh, that's the review, Mr. Dewick. Nice try. Quiz 3, Mr. Dewick. Absolutely number 1, there's going to be an Atwood machine. Okay? Something like number 2, where instead of just saying find an acceleration with friction, I'm going to have an additional vertical force, either lifting up or pushing down. In other words, Ethan, the normal force is not going to be mg. Okay? But look. You can figure out another force the same size as a normal force. Everything up equals everything down. 3 is good. 3, I was going to say 3 would be a multiple choice question if it was on your test. It is a multiple choice question, so that works. I like number 4, I like number 4, I like number 4. I like number 5, I like number 5, I like number 5. Can you look at the big unit review that I gave you? This one, unit 5 review. Most of this stuff looks okay to me. I stole these from the internet, so some questions are going to be talking about static friction or kinetic friction. I've told you we're just going to pretend there's one type of friction, so if it says find mu. These are all pretty fair game. I like number 12. I like number 11. I like number 12. I like number 11 in particular. 12 and 11. 3 is an Atwood machine. I like number 3. Oh, 2, elevator question. I like number 2. So 2, 3, 11, 12. Oh, here's a good example. Look at number 12. Is the mass of the rocket 9,650? No, I gave you the weight. Before I do any... Oh, that's why part A said find the mass of the rocket. I'll have to divide by 9.8. Right? I like number 16. Number 16. I gave you the mass. Yes? I gave you the weight, and what I'm asking you to find in part A is G on this planet. How could you find G on this planet if you know the weight and you know the mass? If the force of gravity equals mg, and I want you to find G on this planet, how could you do that? Go 576 divided by m. You'll get something different, not 9.8. Why? You're on another planet. It's going to be different. And now that you know G on that other planet, you can find the different weights on that planet. Is that okay? So 16 is good. 17, elevator question. 18, I already said I like. 19 is good. Oh, 20, I forgot to cross out on my, but 20 cross out, right? And 21 cross out, is that what we said? Okay. And I think everything else here is pretty fair game. Number 24, giving you a hanging cliff and finding a coefficient of friction. That's about as tough as I might throw at you. In fact, probably that would be a multiple choice question rather than a written, so that only 1 mark, even though it's lots of work. But fair game. 26 I like, 27 I like. So, were there any questions that from this review that you looked at that you're saying, Mr. Duick, I have no idea how the heck to do these? Now is your chance to ask. I don't have a handwritten showing all my steps answer key for this, but I'm pretty sure the answers are right. You tried it already? Sure. I would say M1G, normal force 1, tension. It does say there's friction. Well, there has to be friction because if it was ice, there's no way that this could be hanging over the cliff. It would be falling. M2G, tension. Who's winning? Well, technically it's a tie, but if you wanted to, you could let this way be the winner. You'd get M2G minus tension minus friction force 1 equals M1 plus M2 times A. But the key to realize here, Robbie, is A is 0. Really what you have is that. Yay. Really what you have, if you then plus this over to this side, is M2G equals friction force 1. Friction is what times what? M2G equals mu times the normal force. How would I get mu by itself? Because that's what this question wants. Divide what? So to move the normal force to the bottom of the other side, you're saying? There. Oh, I don't know the normal force. Oh, but look. I know another force the same side. Yeah. This would be trickier if it was accelerating, because that wouldn't have been 0. I would still plus the friction over. I would have just minus the M1 plus M2 times A in brackets, and you'd have one more term sitting there. It'd be more typing. Okay. Is that all right? That's how I'd handle that. Hopefully I didn't do anything new there. Just walked through it. By the way, the reason it says nasty question is last year with my Physics 11s, I didn't do as much on friction. I spent a lot more time on it. So hopefully you can handle it a little easier. Any others? So I'm going to give you the remainder of class to work on the review. I'm doing a tutorial tomorrow after school. I'm having tech issues, so I hope to be able to upload the tutorial, I hope. But if something goes wonky, then something goes wonky. Right click.